Okay, although the other concepts that we've discussed are important, they actually lead up to this, verifying identities. This is kind of one of the big ideas of this section and of this chapter. Okay, it's probably the largest. To verify identities, manipulate one side of the identity until it matches the other. To do this, you will often need to use fundamental trig identities or a variation of them to substitute, okay, for expressions. All right. So it says use the fundamental trig identities to verify the given identity. I have this minus on here. This should really be a plus. Sorry. So it's just positive cosine squared. Okay, so what we're going to do, we could work either side of this identity and make it into the other. However you want to do that. I'm going to choose, in this case, to work on the left-hand side. You could work on the right-hand side if you wanted. But once I determine that I'm going to work on the left-hand side, I can only manipulate that side. So what I'm going to do here is, I see two factors here. I need to get to one term, okay? So I'm going to go ahead and multiply these out. Now if I do that, you should recognize that this is the difference of squares. So I'm going to get 1 squared minus sine squared alpha, okay? Which is just 1 minus sine squared alpha. Okay, now, if we look and we're trying to get to cosine squared here, the fact that I have a sine squared, and a cosine squared should lead me back up to the idea that I have an identity that relates all of these things. Okay? Well, so happens to be that sine squared, 1 minus sine squared equals cosine squared. So what we can do here is just use that identity to say, well then 1 minus sine squared alpha has to equal cosine squared alpha. And that verifies my identity. Notice I worked on just one side and I got it to match the other side. That's the main goal of verifying identities. So let's take a look at another one here. I have cosine plus sine plus sine tangent equals secant. Okay? Now, 6.2 will actually end up doing a lot more technique work here, but I'll throw this in there. We need to manipulate one side to make the other. I'm going to work on the left because it just looks like it has more to, we can do with it. Now, a pretty common thing to do here is when I have multiple trig functions. See, I have 4 different trig functions in this problem. I have a cosine, a sine, a tangent, and secant. I'll often just write everything in terms of sines and cosines. So I get a cosine theta plus sine theta, and tangent by the quotient identities is sine theta over cosine theta. Okay. Now since I'm working on the left, I can only manipulate the left. But this is what I get. I get cosine theta plus sine squared theta over cosine theta. And I'm trying to get to secant here. So let's just take a look at something. Although I'm not allowed to work on this side, I can make a note that secant is 1 over cosine theta. So if I think, I'm trying to get a 1 over a cosine. All right. What's kind of nice at this point is I do have a cosine in my denominator. And see, I have multiple terms. I have 2 different terms there, and I'm just trying to get to one single term. I'm going to go ahead and add these together. Now to add them, I would have to multiply this and get a common denominator, cosine over cosine, which is going to give me cosine squared theta plus sine squared theta all over my cosine theta, since I have a common ratio, or a common denominator, I'm sorry. Wow. Okay, now, I should get pretty excited because cosine squared plus sine squared, if I know my Pythagorean identities, equals 1. So really, the top can be rewritten here as 1, and my denominator is cosine, so I get 1 over cosine theta. And notice, it's what we were kind of trying to get to, which equals secant theta. And that verifies my identity. So there was a lot going on here, but we did verify that the left-hand side is the same as the right-hand side. And that's it for verifying identities.